Hello everyone, welcome you all to another video of data science series. In this video, we will understand about dimension reduction. So let's start. Identifying multicollinearity. Multicollinearity refers to the situation where two or more dependent variables in a regression model are highly correlated. This can cause issues because it becomes difficult to determine the individual effect of each predictor variable on the target variable, leading to instability in the estimated coefficient. To identify multicollinearity in Python, you can use correlation matrix, variance influence factor, or eigenvalue. The most common approach is to compute the VIF, which quantifies how much the variance of regression coefficient is inflated due to multicollinearity. A step-by-step demonstration to identify multicollinearity. Step 1 is to checking correlation matrix. The correlation matrix helps identifying pairwise correlation between features. If the correlation between two features is very high, typically about 0.8 or 0.9, then multicollinearity might be present. Now, step 2 is variance inflation factor. The VIF quantifies how much a variable is inflating the variance of the estimated regression coefficient due to collinearity. A high VIF value indicates that a feature has high multicollinearity with other features. Steps to calculate VIF. For each feature, calculate the VIF by regressing it on the other features. Second, if the VIF is above a threshold, commonly 10, multicollinearity is considered problematic. Now, apply principal concepts. Components analysis. Principal component analysis is a dimensionality reduction technique used to reduce the complexity of high dimensional data while retaining as much information as possible. It does this by transforming the data into a new set of variables called principal components, which are orthogonal and ordered in such a way that the first few components retain most of the variation in the data. Now, here are the steps for this. Step 1 is to loading the dataset. We use the load iris function from sklearn.datasets to load a sample dataset. Step 2 is standardization. PCA requires the data to be standardized, so we use standard scaler to scale the features. Third is PCA transformation. We used PCA to reduce the data to two principal components. And step 4 is variance expand. The expand variance ratio attribute shows how much variance each principal component explain. Step 5 is visualization. The scatter plot visualize the first two principal components colored by the target class. And here's the code for this. First of all, we will import all the libraries. Import numpy as np, import pandas as pd, import matplotlib.pilot as plt. From sklearn decomposition, import pca. From sklearn.preprocessing, import standard scale. From sklearn.dataset, import load iris. Step 1, load dataset using the iris dataset from this example. Data equals to load iris. This will help to load the dataset. X equals to dataset, this will contain the features. Y equals to data.target, this will contain the labels. And step 2, standardize the features. Scalar equals to standard scalar. S scaled equals to scalar.fit transform. And this is for the standardization features. And step 3 is to apply PCA. PCA equals to PCA and components equals to 2, reducing to two components for visualization. XPCA equals to PCA.fit transform at S scaled. Step 4 is explain the variance. print explained variance ratio, which is PCA dot explained variance ratio, and print total variance explained by the two component NP dot sum PCA explained variance ratio. Now step 5 is to plot the two principal components. PLT dot figure, figure size equals to 8 comma 6, PLT dot scatter XPCA, and XPCA equals to 1, and C equals to Y, C map equals to Viridis. Now PLT dot color bar, this will help to print a bar with color, and PLT dot X label will contain principal component 1, and the Y label will contain the uh, principal component 2, and the title will be PCA on iris dataset, and PLT dot show will show the plot. Let's run this code in the Google Colab. Here is the code. Let's run this. So this kind of plot will be drawn from the data, which contain principal component on the x-axis and principal component 2 on the y-axis, and PCA on iris dataset is the heading of the graph. That's all about this video. Thanks for watching.